Hey everyone! Welcome back to Learning Bot channel. In this video, we're taking a plunge into the dynamic realm of programming, exploring Python, an exceptionally versatile and beginner-friendly language that opens the doors to endless possibilities. Python is like the Swiss Army knife of programming languages. It's powerful, yet easy to read and write, making it perfect for beginners. Whether you're dreaming of creating websites, diving into data science, or even exploring artificial intelligence, Python has got your back. One of the things that makes Python so awesome is its simplicity. The syntax is clean and straightforward, allowing you to focus on solving problems rather than wrestling with the language itself. And let's talk about community support. It's incredible. There's a vast community of Python enthusiasts worldwide, ready to help you on your coding journey. So, whether you're stuck on a bug or just curious about best practices, you're never alone. Now, here's the exciting part. Python is not just for experts. It's for you. If you've never coded before, Python is an excellent place to start. But, it's also loved by seasoned developers for its scalability and wide range of applications. So, if you're ready to unlock the world of coding, Python is your key. The first crucial step on your Python journey is setting up your coding environment. And what better way to do it than with PyCharm, one of the most powerful and user-friendly Python IDE. If you're wondering what PyCharm is, think of it as your coding best friend. It's an integrated development environment that makes the coding process a breeze. And hey, stick around, because today, we're not just getting to know PyCharm, we're creating our first Python application with it. Let's first make sure you have Python installed on your machine. Don't worry, I've got your back. Head over to python.org and grab the latest version. You'll find the link in the description below. Once the download is complete, let's install Python. Follow the on-screen instructions, making sure to check that Add Python to Path box. This will make your life easier down the coding road. With Python installed, now it's time to meet PyCharm. Go to jetbrains.com and download the PyCharm Community Edition. It's free and perfect for beginners. Once the download is done, run the PyCharm installer and feel free to adjust the installation location, or choose whether to create desktop shortcuts. With PyCharm installed, let's open it up. Click Create New Project. Choose your project's location and select the Python interpreter you just installed. This is like the engine that runs your Python code. Also, select your development environment. If you're new to this, starting with Virtualenv or PyPen is a great idea. They're straightforward and widely adopted. Once you've created a new project in PyCharm, you'll be greeted by the project window. This is your coding cockpit, where the magic happens. On the left, you've got your Project Explorer. This is where all your files and folders live. Now, let's talk about that mysterious Ven folder. When you chose a virtual environment during project creation, PyCharm creates a dedicated space for your project's dependencies. It's like a bubble where your project's Python interpreter and packages live independently. Why is this important? Well, it keeps your project self-contained, preventing conflicts between different projects. It's like having a clean slate for each project you undertake. Now, let's add some code to our project. Right-click on your project folder, select New, and then choose Python File. Give your file a name. How about Hello? Click OK, and there you have it, a blank canvas for your Python masterpiece. Now, let's write our first line of code. In Python, printing is as easy as it gets. Type print, then add parentheses. Then add quotes, and inside these quotes, write Hello World. Hit the green play button or right-click and choose Run. There it is, you've just written and executed your first Python code. The journey of 1,000 codes begins with a single Hello World. Now, let's dive into a fundamental aspect of any programming language, which is variables and data types. Buckle up, this is where the real fun begins. Variables act as temporary storage for data in a computer's memory. Think of them as labels we attach to specific information, like the price of a product, someone's name, email, or age. Now, let me guide you through this with a fresh example. To declare a variable, we start by giving it a name. Let's call it age. We use the equal sign to assign a value. For instance, let's set it to 25. So, age equals 25 means we have stored the number 25 in our computer's memory and labeled it as age. Now, let's print this variable on the terminal. Instead of the usual hello world text, we type print age to display the value of the age variable. Make sure not to use quotes, otherwise, it'll print the word age instead of its value. Now, by clicking on the play icon in the toolbar, we run our program and see the value of age. Changing values is a breeze. For instance, we can set age to 30. Run the program again, and voila, the updated value is displayed. Python reads our program from top to bottom, executing each line. It's that straightforward. Now, let's explore more variable types. I'll create another one, price, and set it to 20.15. In Python, we can work with decimal or whole numbers seamlessly. Also, we can declare a variable with a string value. Consider first name. Notice the use of underscores for multiple words, enhancing code readability. I'll set it to Peter using single quotes. Oh, and don't forget about Boolean values. Let's create is online and set it to true. You can also use false. These are like binary choices, representing yes or no in Python. A crucial note, Python is case sensitive. So, false with a capital F is recognized, but false with a lowercase f would trigger an error. Python interprets uppercase and lowercase letters differently, so it's vital to be mindful of that. And there you go, that's the essence of declaring and utilizing variables in Python. Quite thrilling, don't you think? Let's now stepping up our Python game. In our last tutorial, we tackled variables, and now, get ready to interact with your code, using the powerful input function. In Python, the input function is your go-to for receiving user input. Let's dive right in. When using input, we add parentheses and then type in a string, like "What is your name?" with a space after the question mark. That space ensures a neat user interface. Let me demonstrate. Running the program, we prompt the user for input. Notice how the cursor neatly aligns with the question mark, making it user-friendly. Let's enter a value, say Peter, and hit enter. The magic happens when we press enter. The input function returns the value entered in the terminal. Now, let's elevate this by storing it in a variable. We declare a variable, name, and set it to the return value of the input function. Now, let's print a personalized greeting using the print function. We say hi, add a space, and then use the plus sign to concatenate the string with the value of the name variable. This process, called string concatenation, merges strings seamlessly. Running the program again, we ask, "What is your name?" Enter Peter, and boom! We get, "Hello Peter." That's the power of the input function and string concatenation in Python. It's all about making your code interactive and user-friendly. Next in this tutorial, we're delving into a crucial aspect of Python, which is variable conversion. Understanding how to convert between different data types can save you from those pesky errors. So, let's dive right in. In Python, we deal with three types of data: numbers, strings, and booleans. But what happens when you need to convert the value of a variable from one type to another? Well, that's where our trusty built-in functions come into play. Let me demonstrate. We'll start by using the input function to read the user's birth year. The value returned by the function is automatically a string, so we store it in a variable named birth_year. Now, let's calculate the user's age. We take for example the current year, 2023, minus the birth year. But wait, running this crashes our program. That's because we're trying to subtract a string from an integer. The error message tells us we have unsupported types for subtraction, int and str. Int stands for integer, and str represents a string. When we use the input function, it returns a string, even if we enter a number. To solve this, we introduce the int function. This magical function converts our birth year string into a numeric representation, allowing for smooth subtraction. And there we go. By using the int function, we have successfully calculated the age. Running the program with a birth year of 1981 will return 42 years old. But that's not all. Python offers a variety of built-in functions for different conversions. We have float for floating point numbers, bool for booleans, and str for strings. Whether you're dealing with integers, floats, booleans, or strings, Python's got you covered with these versatile functions. Next in this tutorial, we're unraveling the fascinating world of strings in Python. Brace yourself for some mind-blowing capabilities. Let's kick off by declaring a variable, say, word, and setting it to Python for fun. Now, this string is not just text, it's a full-fledged object in Python. Think of it like a Swiss Army knife. This string object comes packed with capabilities, or as we call them, methods. Type word, dot, and witness the magic unfold. These are methods specific to strings. For example, the upper method transforms our string to uppercase. So if we print word.upper and run this program, we can see our word in uppercase. Pretty useful. But here's the trick, this doesn't alter the original string, it returns a new one. So right after, if we print word, you can see that our course variable is not affected. We also have the lower method, which does the opposite. And how about finding characters? Enter the find method. Pass a character or sequence, for example, n. When we run this program, you're going to see on the terminal the index of the first occurrence of n, starting from 0. We can also pass a sequence of characters, for example, 4. So, this will return the index of the word for. Take a look. It's 7. Hold on, Python is case sensitive. If you seek an uppercase n in our string and don't find it, you get a -1. Now, the replace method steps in when you want to switch things up. Replace 4 with a string containing the number 4. Run the program again and voila! Exciting, isn't it? But what if you're on a quest to replace something that isn't there, like x? Nothing happens. Python is cool like that. Lastly, we often want to check if a string contains specific characters. The find method can do this, but in Python, we have the elegant operator, in. Expressions like Python and Word give us a clear yes or no. Python's readability shines, just like plain English. Next in this tutorial, we're diving into the world of arithmetic and logical operations in Python. Buckle up as we explore the operators that make mathematical and logical magic happen. First things first, let's talk about the arithmetic operators in Python. They're the same operators you know from math class: addition, subtraction, multiplication, and division. Let's kick things off by printing the result of 5 plus 4. Running this program gives us 9. That's the addition operator in action. We've got subtraction, multiplication, and division, but here's where it gets interesting. Python has two division operators, a single slash for floating point numbers and double slashes for integers. Watch closely as we explore the nuances. If you use a single slash, we get a floating point number, a number with a decimal point. But if we use double slashes, we get an integer, a whole number. Adding to the mix, we have the modulus operator, giving us the remainder, and the exponent operator, raising a number to the power of another. Now, let's talk efficiency. Python offers augmented assignment operators for all these operations. If you have a variable, say x, and you want to increment it by 2, you can use x plus equals 2. It's a concise way of expressing the operation. Same goes for subtraction, multiplication, and more. These operators make your code cleaner and more readable. Time for a challenge. What's the result of x equals 5 plus 2 times 4? Before you answer, consider operator precedence, the order in which operations are applied. Multiplication and division take precedence over addition and subtraction. This part of the expression gets evaluated first. So 2 times 4 is 8, and then the result is added to 5. That is why the result of this expression is 13. But fear not, you can always override this with parentheses. Wrapping changes the game, giving us 28 instead. Python respects parentheses, just like good old math class. Next, besides the arithmetic operators, we have a squad of operators, called comparison operators. They are the detectives of Python, comparing values and delivering the verdict. Observe as we declare a variable, x, and set it to 5 greater than 4. This expression is what we call a Boolean expression, and it's shouting true, because 5 is indeed greater than 4. We've got an arsenal of these. Greater than or equal to, less than or equal to, equal, and not equal. These are your go-to tools for evaluating conditions in Python. Remember, these operators are the backbone of real Python programs, helping us make decisions based on values. But hold on, there's an additional operators to explore, the logical operators. These bad boys help us weave intricate rules and conditions. Follow closely as we declare an age variable and set it to 50. Now, imagine we want to check if age is between 20 and 60. This is where we use the AND operator. If both Boolean expressions return true, the whole expression gives us true. Now, let's shake things up with the OR operator. If at least one expression is true, the whole gang is true. Watch as we change age to 15 and let Python work its magic. So the result of this entire expression will be true. There's also the rebellious not operator, inverting any value you throw at it. We're going to have one Boolean expression, age greater than 20. The result of this expression is false. Now if you apply the not operator, this will inverse false to true. Now, it's decision-making time, as we unravel the power of if statements in Python. Picture this, if statements are like the guardians of our code, making decisions based on conditions we set. Let's dive right in. We'll declare a variable, age, and depending on its value, decide if someone is eligible to vote. Initially, we'll set the age to 18. Now, consider this scenario, if the age is greater than or equal to 18, we want to convey a specific message. To achieve this, we utilize an if statement, along with comparison operators. For instance, we check if the age is greater than or equal to 18. The subsequent colon indicates the beginning of a code block. The indented code within this block executes only if the condition holds true, otherwise, it's bypassed. In if block, we print you are eligible to vote. By pressing enter and indenting further, we extend the block, allowing additional messages to be printed if the condition is met. For example, we print make sure to exercise your right to vote. To conclude this block, we remove the indentation by pressing enter and then shift tab. This ensures that the following code is executed regardless of whether the previous condition is true or false. Running the program displays the corresponding messages, illustrating the flow of the program based on the age value. Now if I change the age to 16 and run the program again, we don't see anything. After this block, let's print done. Because this code is not indented, it will always get executed because it's not part of our if block. Okay, take a look. Here's the done message. Now, let's introduce a second condition. elif, a short of else if. And then age less than 18 and greater or equal to 16. Then we're going to print, you are not eligible to vote, but you will be soon. In this case, if this condition is true, that means the age is between 16 and 18. Now let's run the program and verify this. There you go. The age is 16, that's why we see the message you are not eligible to vote, but you will be soon. Following this block, let's add an else statement. Else, followed by a colon, and now we have a new block. This code will get executed if none of the above conditions are true. Here we can print a general message like, "You're not old enough to vote yet." It's worth noting that double quotes are used to encapsulate the string, to accommodate the single quote within the message. If I typed "you're not," Python gets confused because it thinks the single quote represents the end of our string, so it doesn't recognize the subsequent characters. So, we use double quotes here to have an apostrophe in our string. Now let's run the program with age set to 15. There you go. We see the default message in the else block. Importantly, the flexibility of if statements allows for the incorporation of numerous conditions to suit the program's requirements. This demonstrates how if statements are fundamental in making decisions within our Python programs. Here's a great exercise for you to practice what you have learned so far. In this exercise, we're going to use an if statement to determine the nature of a given number, whether it's positive, negative, or zero. So go ahead and spend 5 minutes on this exercise. You can use the comment box below to share your code with others. Then, when you're done, come back, see the solution. So first we call our input function to ask for a number and then store it in a variable called number. As input function always returns a string, so here we need to convert the input to a number using the float conversion function. Now, our goal is to check whether this number is positive, negative, or zero. We begin with an if statement followed by the condition number greater than 0, indicating that if the number is greater than 0, a certain block of code will be executed. Inside this block, we print a message saying the number is positive. To add more complexity, we introduce an elif statement, which allows us to check additional condition if the preceding one is false. In this case, we check if the number is equal to 0. If true, we print the number is 0. Finally, we implement an else statement, which executes if none of the preceding conditions are met. In this block, we print the number is negative. Now, let's try entering a number, let's say -7. Run the program and voila! The negative value triggered the else block, and the message, "the number is negative," would be printed. Next in this tutorial, we're going to talk about while loops in Python. We use while loops to repeat a block of code multiple times. Let's consider a scenario where we want to calculate the square of numbers from 1 to 5. Writing individual lines of code for each calculation is impractical, so this is where while loops come in handy. We'll start by declaring a variable, let's call it number, and set it to our initial number, say 1. Then we use the while keyword and specify a condition, for example, number less than or equal to 5. As long as this condition is true, the code inside the while block will be executed. So, we type a colon and press enter. Inside this block, we can calculate the square of the current number by multiplying it by itself. Let's print the result. Here, we use the scr function to convert numerical values to strings, so we can concatenate them with the string message. Additionally, we need to increment the number by 1 in each iteration to avoid an infinite loop. Now, let's run this program. We'll see the squares of numbers from 1 to 5 printed on the terminal. This demonstrates the efficiency of while loops in handling repetitive tasks without the need for redundant lines of code. Now, here's an exercise for you about using while loop. In this exercise, we're going to create a program that calculates the sum of numbers entered by the user until a specific condition is met, for example, 0. So go ahead and spend 5 minutes on this exercise. You can use the comment box below to share your code with others, and then, when you're done, come back, see the solution. So, we start by initializing a variable called total sum to 0, and we ask the user to enter a number using the input function. Don't forget to convert the input to a number using the int conversion function. Then, we use a while loop with the condition number not equal to 0 to keep iterating as long as the user doesn't enter 0. Inside the loop, we add the current number to the total sum variable. Next, we prompt the user to enter another number. The loop continues until the user enters 0, at which point the loop exits. Finally, we print the sum of all the entered numbers. Now, let's try to run the program and entering a number, let's say 4, and then 2. Next, we enter 0, to exit the while loop and get the sum result. Next in this tutorial, we're delving into the fascinating world of lists. Whether you're a beginner or looking to sharpen your Python skills, understanding lists is a must. We use lists whenever we want to represent a list of objects, like a list of numbers or a list of names. Let me show you, so I'm going to declare a variable called days, and set it to a list of days. Here, we add square brackets to represent a list. And now we can add one or more objects inside this list. In this list, we add a bunch of days like from Monday to Friday. We separate these items using a comma. Now let's print our list. Take a look, it comes out exactly like how we wrote it. Now we can also get individual elements in this list. For example, if we want to get the first element in this list, we type a pair of square brackets, and inside the square brackets, we type an index. The index of the first element in this list is 0, so now when we run this program, we're going to see Monday on the terminal. In Python, we can also use a negative index. If 0 represents the first element in this list, then -1 represents the last element in this list. Let's verify it. So let's run the program, and here's Friday. What about -2? Well, that represents the second element from the end of the list. Let's run the program, and here's Thursday. We can also change an object at a given index. For example, let's say here we made a mistake, and this Monday should not be capitalized. So we need to reset it. We type days with index equal to 0, and set it to the new value. Now, let's print our list, and here's our updated list. We can also select a range of values. For example, let's say we're only interested in the first 3 days. So over here, we type square brackets, and here we need to type 2 indexes, a start index, and an end index. Our start index is 0 because we want to start from the first, and our end index is going to be 3. So, Python is going to return all the elements, from the start index, up to the end index, but excluding the end index. It's going to return the elements at index 0, 1, and 2. Take a look, here are the first 3 days. And by the way, this expression does not modify our original list, it returns a new list. So, right after this print statement, if we print our original list, you can see that it's not changed. This is how we use lists in Python. Now, let's explore advanced list techniques that will empower you to handle data like a pro. Let's jump in. Just like strings, lists are also objects. So they have a bunch of methods for adding items or removing them and so on. Let me show you, so I'm going to declare a list of days from Monday to Friday. Now, to add a new day, at the end of this list, we can use the append method. So we type days.append, and then we type Saturday. Next, let's print our list. So, here's our updated list. Hold on. What if you want to insert a day, somewhere in the middle or at the beginning? For that, we use the insert method. The first value that this method expects is an index value, and the type of this value is an integer. So, if I want to insert a value at the beginning of this list, I should pass 0. The second value is an object with any type. So, I'm going to pass Sunday. Now, let's run our program. You can see Sunday appeared at the beginning of our list. We also have a method for removing items. So, let's call remove Wednesday. Run again the program. Look, Wednesday is gone. Now, if you want to remove all the items in the list, we call the clear method. This method doesn't expect any values. Let's run our program and voila, our list is empty. Sometimes, you want to know if a given item exists in our list or not. To do that, we use the in operator. So, instead of printing our days list, I'm going to print an expression. I type Monday, and then the in operator, followed by the list days. So here we're using the in operator, we're checking to see if Monday is in the days list. So, this is a Boolean expression, it returns a Boolean value. Take a look, so we get true. Obviously, if we search for a value that doesn't exist in this list, like Python, we get false. Now, finally, there are times you want to know how many items you have in the list. To do that, you can use the built-in len function. So, let's print len and then days. So len is a built-in function just like the print function. It returns the number of elements in a list. Take a look, so we have 7 elements in this list. In the final segment of our Python Basics tutorial, we're diving deep into the world of Python for loop and unravel the power of iteration. For loops in Python are your go-to tool for iterating over a sequence like a list or a string or any iterable object. Their syntax is concise and elegant, making them perfect for various tasks. So, let's declare a list of names, starting from John to Charlie. Now, if we print this list, it comes out exactly like how we wrote it, using the square bracket notation. But what if we wanted to print each name on a separate line? That's where we use the for loop. Let me show you. Instead of printing the entire list, we're going to type for. Next, we declare a variable, which is called a loop variable. Let's call it name. Then we type in, and then names, which is our list. Next, we add a colon to start a block of code. This is what we call a for loop. With this for loop, we can iterate over all the items in this list. In each iteration, the name variable is going to hold one value. So, in the first iteration, name is going to be John, and in the second iteration, it's going to be Bob, and so on. Now, if we print name and run our program, we see each name on a new line. This is how we use a for loop. Indeed, we could also achieve the same thing using a while loop, but our code would be a little bit longer. Let me show you. First, let's encapsulate our for loop within a comment block, using the hashtag keyword to prevent its execution. Next, we start by declaring a loop variable outside of our while loop. Let's say x, and we set it to 0. Now, we type while, and then x, less than len names. Here, we need to find out how many items we have in this list, so we use the len function. Inside the while block, we need to print a name from the list, as long as x is less than the length of the list. Next, we need to increment x by 1. Let's run the program and see what we get. So, we get the names from John to Charlie. Now, if you compare these two approaches, you can definitely see that the implementation using the for loop is shorter and easier to understand. While loops are handy when you don't know the number of iterations in advance, or when you're dealing with complex conditions. However, for loops shine when you're working with a predefined sequence or iterable. If you found this tutorial enlightening, smash that like button, subscribe for more coding mastery, and hit the notification bell. Happy coding, and I'll catch you in the next tutorial.